Hello, so in this video tutorial, I'm going to show you how to use the CK12 Exploration Series Atom Builder Simulation. So when you click on the link to go to the simulation, the question that we're going to be answering today is how are elements different from one another? And we're going to be using the simulation to help us think about how the periodic table is organized and how it relates to the structure or the particles that are inside the nucleus of the atom. So once you click on the play button, it'll give you a little bit of an introduction. It says all matter is made up of atoms, and it gives you some examples of different atoms. Atoms are the smallest stable unit of matter, but they aren't the smallest piece of matter. So let's look inside the atom and look at the structure that we've been learning about. We've been learning that atoms are made up of protons, neutrons, and electrons. So here you see a model of an atom. These are the three different subatomic particles that we've been learning about. So in our simulation today, we are going to build the atomic structures of these atoms to help us learn about the periodic table and atomic structure. So I'm going to click on this link that says Go to Sim. So you'll see that I have these missing pieces on the periodic table, and our task is to build the atoms for the missing elements. So I'm going to click on this first one right here, beryllium. Now, using this information from the periodic table, we can build a beryllium atom. So let's think about what's on the periodic table. We know that we have the atomic number and that we know that we have the average atomic mass of beryllium. So we know that there are 4 protons in the nucleus and that beryllium probably has a mass close to 9. So let's start with the protons. We know that we need to add 4 protons to make this a beryllium atom. So at the slider at the bottom, right here at the bottom of the screen, I'm going to slide it over to number 4, beryllium. So I've got my protons in the nucleus, but I'm still missing some pieces. In order to make this stable and neutral, we have to have a neutral charge. So if I have 4 positive charges, I need to counteract that with 4 negative charges. So I'm going to add in 4 electrons. So I'm going to move my slider until I have 4 electrons. Now notice these electrons naturally arrange themselves in these energy levels. There's 2 electrons in the inner circle, and there's 2 electrons on the outer circle. The outer level is what we call valence electrons. So even though we have 4 total electrons in this atom, only 2 of them are on the outside. So this beryllium atom has 2 valence electrons. That's going to be important in our assessments this week. The last thing we need to add is to add some neutrons because our nucleus is still unstable. So let's add some neutrons to give this a mass close to 9. Well, what number plus 4 would equal 9? I'm going to add in 5 neutrons, have a mass number of 9. So let's see if I got it right. I'm going to click this submission button. Good job. I've made an element of beryllium. Now we're going to make different elements. Okay, so you guys can pick on these different atoms to practice building atomic models. Then, once you guys have completed all the practice problems, I want you to use this simulation to answer the questions on your assessment. So let's go to the assessment and look at some of these questions. On page 2, it tells us to build lithium, sodium, potassium, rubidium, and cesium. Okay, so let's think about how many protons, electrons, neutrons, and valence electrons will be in each one of these atoms. I'm going to start with lithium. So if I go back to the simulation, if I'm going to make a model for lithium, well, let's go to the periodic table. Lithium has 3 protons. So let's go to the simulation and build an atom with 3 protons. Okay, well, how many electrons is lithium going to have? Again, we want our atom to be neutral, so if I have 3 positive charges, I need to add in 3 negative charges. So I'm going to move my slider over to 3. 1, 2, 3. Notice 2 of these electrons are in the inner shell, and 1 of these electrons is in the outer ring. It's a valence electron. So lithium has 1 valence electron. Okay? Now let's look at the number of neutrons. Lithium is a small atom, so I'm going to add in 3 neutrons for 3 protons because the 1-to-1 ratio works well for small atoms, and this is a stable isotope of lithium. Okay, this is a model that I can draw or take a screenshot of or make a Google drawing of the lithium atom. So you guys will want to do that on your assessment, is to take a screenshot or a picture of this model to include in your assessment. Okay, let's fill out the table. How many protons does lithium have? Well, if I go to the simulation, it says 3 protons in a lithium atom. So I'm going to type in 3 protons. How many electrons? Well, again, I look at the simulation and I added 3 electrons here. So I'm going to type in 3 electrons. Number of valence electrons. How many of these electrons were in the outer ring? We'll have 2 that are in the inner energy level and 1 that's in the outer energy level, or a valence electron. So lithium only has 1 valence electron. So I'm going to type in 1, and then I'm going to count the total number of energy levels or rings in this model. So there's 1, 2 energy levels. So I'm going to type in 2. Okay, and again, you will either need to insert a Google drawing of this atom creating in Google Drawings, or you can take a screenshot of this model that you built in the simulation and insert that model there. But you'll need to make models for all of these atoms in the table. Okay, that is how we're going to use the atom builder simulation to complete this part of the assessment. Okay, I hope that helps make this part of the assessment a little bit more clear. If you need other help or if you have questions, please talk to me. Please send me an email. Please reach out to me so you can get help on this week 8 assessment.